I feel like I need to do one more for you that's a little bit more extensive when we are dealing with like two draws of something or two dice or two flips of a coin, three flips of a coin, and kind of show you how the tree diagrams are helpful when we're looking at these. So again, these are conditional probability. And for this next example, and this actually comes right from the worksheet that you're going to be doing. So a bag contains one red marble, one blue marble, one green marble. And they tell us a marble is drawn, put back in the bag, and a second marble is drawn. So we have that dependent event happening here with the conditions, some conditions on it as we go forward. Let's look then at the tree diagram, and this might be helpful for some of you to draw this out. So if I have a bag, it contains one red, one blue, and one green marble. Then when you draw the marble, so this would be my first draw. I can draw any one of those out of the bag. The second draw then is going to be my first set of limbs on the tree, right? So I'm going to put the marble back and then draw a second one. So I can, on the second draw, I could draw another red, I could draw a blue, and I could draw a green. And that could be the case if I drew a blue first, I could draw a red, I could draw another blue because I put it back in, or I could draw a green. Here I would have a green, I could draw a red, I could draw a blue, or I could draw a green again because I replaced it. Okay, so they're independent of each other. Each draw is independent because, so finding the probability of each event occurring is independent because we are putting the marble back. So I can get all three outcomes again on the second draw. Now my sample space is really going to be then, if I list these out, I'm going to have 9 possible outcomes. R, I could draw a red, blue. I quickly drew the rest in there not to waste your time. So there are all the samples, or the sample space, I should say, and I have 3, 6, I have 9 outcomes in my sample space. Okay, so you might need to identify that first when you are working through the problems on the worksheet. And then from there, we're going to use the formula to find the conditional probability. So here we have the probability that a red marble is drawn. So I'm going to try to use my conditional probability notation. So we have the probability that a red marble is drawn given that a blue marble is drawn. So I'm going to represent that with notation like this. Using my formula then, I know that I'm finding the probability of a red and a blue being drawn. And I'm going to divide it by the probability of me drawing a blue. So again, I have 9 outcomes. So each of these probabilities to begin with are going to be out of 9. Okay, the probability of me drawing a red and a blue is going to be where I have RB or BR. So I have one possibility here and one possibility here. Therefore, I have 2 out of 9 chances of getting a red and a blue. The probability of me drawing a blue is going to be any of these outcomes that have a B in that. So I have 1, I have 2, 3, 4, and 5. So 5 out of 9 gives me the probability that I draw blue. And then when I divide those, remember you multiply by the reciprocal. So I have 2 9s divided by 9 fifths, or times 9 fifths. My 9s really just cancel each other out. And I end up with a probability of 2/5 for me drawing a red marble given that the blue marble is drawn. Looking at 10, then it says what's the probability that a green marble is drawn. So probability of a green given that 2 marbles drawn are the same color. So that's how I would notate it. The given part is second. So if I'm going to use the formula, I'm going to use the probability of getting a green and two same color over the probability of two the same. Okay, I'm going to come down here and keep going with that. But the probability of a green and two the same, okay, we are only going to have one chance out of 9 where they're the same and we have a green, and that's this case right here. Okay. On the bottom then, the probability of having two of the same color, well, that's RR, BB, and GG. So I have 3 out of 9 chances for them to be two of the same color. And now I go ahead and multiply by the reciprocal. Notice my 9s cancel, right? They cross cancel, and I get a third for the probability of me getting a green given they are the same color. And again, some of you can look at this tree diagram and pull out that probability just by looking at your outcomes. Now that I've got them listed, I'm kind of showing you more the formula route. Certainly, if that makes more sense to just pull it right away, that's okay also. What's the probability that a blue marble is drawn given that the first marble is green? So the first has to be a green. Difference there, here up here it says the probability that a red is given that the blue marble is drawn. So you could have red, blue, blue, red. Here you have to have that first marble being green. What's the probability that it's a blue? Using the formula, and again, some of you are going to maybe just be able to go over there and figure out that probability from looking at our outcomes, but I'm going to go ahead and go through with the formula. So the probability that you draw a blue and the first, I'm going to put 1G, is green, divided by the probability that you have the first being green. So the probability of it being green, or blue, sorry, and the first one being green, we have to look at all the G ones, and from there, the only one where it's the first one is green and it's a blue is 1 out of 9 choices. I divide by then the probability that the first one is green. Well, if I look at the first one being green, I have 3 possibilities out of 9 where the first one is green. So again, I'm going to multiply by the reciprocal. My 9s are going to cancel out. And I, again, am going to get 1/3 as that probability. This should hopefully help you a little bit with some of the worksheet problems that you're going to be doing for me and handing into Schoology.